Welcome to Module 3 of the SUST 3D Fashion Training, 3D CAD Design Software Applications. In this session, you'll discover how 3D CAD tools redefine fashion processes and empower VET learners to adapt to a digital future. Today's fashion industry is rapidly transforming. Thanks to 3D CAD tools, designers can simulate, prototype, and fit garments virtually, eliminating the need for physical samples in early stages. These tools streamline production, foster creativity, and support sustainability by reducing fabric waste and overproduction. As part of the Industry 4.0 shift, 3D CAD design has become essential in building a circular, environmentally conscious fashion system. By the end of this module, you will understand how 3D CAD supports fashion innovation and sustainability, gain insights into tools like CLO 3D and Optitex, apply digital workflows to accelerate design timelines, enhance collaboration, and reduce waste. Be equipped with practical knowledge to start your own 3D garment design journey. CAD stands for Computer-Aided Design, software used to digitally create, visualize, and modify fashion patterns and garments in 2D and 3D. From flat pattern drafting to dynamic 3D garment simulation, CAD has redefined speed, accuracy, and design visualization in fashion. Let's look at the key benefits of using 3D CAD in product development and fashion design workflows. 3D CAD significantly shortens the time to market by increasing engineering efficiency. Designers can rapidly create and update 3D geometry and associated deliverables, allowing faster transitions from idea to product. Quote, "It enables rapid creation and evaluation of design alternatives. Virtual analysis helps teams reach optimal design decisions quickly, supporting faster product launches. By identifying and eliminating design flaws early, CAD reduces the need for multiple physical prototypes, leading to major cost savings during development." Quote, "Using CAD, designers can optimize performance, quality, and durability. It frees up time and budget for more innovation by minimizing rework and errors. High-quality CAD documentation enhances user adoption and customer service, helping companies stand out through product clarity and consistency." Quote, "Finally, 3D CAD simplifies manufacturing planning and process alignment. It ensures a smooth and accurate transition from design to production." The fashion industry now relies on a range of powerful digital tools to transform traditional workflows. From 2D pattern drafting to 3D garment simulation, these tools enhance design precision, reduce sampling costs, and accelerate innovation. In this section, we'll introduce several industry-relevant CAD platforms, each designed for specific roles, including simulation, pattern cutting, accessory design, and textile graphics. Whether you're a VET educator, designer, or student, understanding the strengths of each tool will help you choose the right one for your educational and professional needs. CLO 3D is a leading 3D garment simulation software used by major fashion brands and institutions worldwide. It allows designers to create, drape, and fit digital garments on customizable avatars. What sets CLO 3D apart is its real-time feedback. Designers can visualize how fabrics behave, test fits, and make adjustments, all before a single thread is cut. By reducing the need for physical samples, CLO 3D promotes sustainability while enhancing speed to market. It's especially valuable in education, where students can build digital collections and understand construction techniques interactively. Let's talk about the workflow for creating a digital garment in CLO 3D. The process begins with 2D pattern creation or importation. These patterns are then arranged around the 3D avatar. Next, the 2D patterns are digitally sewn together. The simulation engine is then activated to drape the patterns into a 3D garment in real time. The garment's fit is refined by modifying the 2D patterns. Any adjustments are instantly reflected in the 3D model, allowing for precise and efficient alterations. Fabric properties, colors, and textures are assigned to the garment to achieve the desired look and physical drape. Finishing elements such as trims, buttons, zippers, and top stitching are added to enhance the design's realism. The final stage involves generating high-resolution, photorealistic images and animations of the completed digital garment for presentation or prototyping. Optitex is a comprehensive CAD/CAM solution for 2D and 3D fashion design, offering tools for pattern creation, grading, and garment simulation. With realistic tension maps and fabric simulations, it enables virtual fittings and production-ready patterns. Used by both manufacturers and fashion schools, Optitex supports creative and technical workflows, helping users reduce costs, increase fit accuracy, and shorten production cycles. Now, let's outline the professional workflow for creating a digital garment. First, the process originates in the 2D environment. Here, patterns are either drafted using the integrated CAD tools or imported from existing digital files. Next, we transition these 2D patterns into the 3D workspace. Each piece is strategically positioned and oriented around a customizable avatar. Then, using a multi-stitch tool within the 3D environment, we define the garment's construction and seaming, accurately mirroring the physical assembly line. In the simulation phase, a physics-based engine drapes the stitched patterns onto the avatar, creating a virtual sample. We conduct a thorough fit analysis to objectively identify and correct areas of stress and ensure a perfect fit. Once the fit is validated, we focus on material properties and aesthetics. The system facilitates accurate fabric simulation and photorealistic rendering. At this stage, we apply specific colorways, logos, and prints, ensuring precise placement and visual accuracy. Finally, the workflow's key advantage is its capacity for real-time iteration. Any modification to a 2D pattern is instantly reflected in the 3D simulated garment. This allows for rapid prototyping and informed decision-making, drastically reducing the reliance on physical samples. The finalized design is then ready for stakeholder review via 360-degree visualizations. Browseware is a 3D fashion platform trusted by global brands for its seamless integration between design and manufacturing. It offers tools like VStitcher and Lotta to simulate garments, evaluate fabric behavior, and communicate design intent to production teams. It's highly valued in both industry and academia for its enterprise-level capabilities and sustainability features, including digital sampling and production optimization. Now let's cover the workflow for creating true-to-life digital garments using Browseware's VStitcher platform. The process begins by selecting a true-to-motion soft avatar and leveraging VStitcher's extensive library of pre-made pattern blocks. From there, we operate within VStitcher's integrated design environment. The system features synchronized 2D and 3D workspaces, allowing our designers to engineer flat patterns, while simultaneously visualizing the three-dimensional results in real time. During this phase, the platform provides instant feedback as the digital garment is being produced. We utilize analysis tools, including tension and pressure mapping, to scientifically validate the fit and performance, thereby mitigating risks before physical sampling. VStitcher's rendering engine achieves hyper-realistic visualizations by applying fabrics from the digital library and layering multiple textures. This allows us to simulate physical properties accurately and see every detail. To further refine the digital twin, we employ a suite of tools. This includes executing fold and hang simulations, adding another layer of commercial realism to the design. Finally, the completed 3D asset is shared with key stakeholders for review via the StyleZone cloud platform. VStitcher's seamless integration with other industry-standard software ensures a fluid and interconnected design ecosystem. Telestia Creator is a CAD system designed specifically for pattern making and fashion education. It enables learners to draft, edit, and print full-scale patterns, even on A4 printers. Based on the Telestia methodology, it simplifies complex construction while ensuring an accurate fit. This makes it ideal for vocational learners, freelancers, and small ateliers looking to digitalize their workflow affordably. Now, let's examine the workflow within Telestia Creator. First, within the fashion design module, a parametric model is generated based on specific body measurements. Next, the design and its corresponding technical drawings are created directly on the virtual model. This integrated approach establishes a seamless and unambiguous communication basis between the designer and the pattern technologist. Telestia Creator enables the visualization and validation of the design's fit on the virtual model before the 2D pattern is finalized. This virtual fitting functions as a critical pre-production check. Leveraging this validated design, we proceed to automated pattern generation. Then, the pattern cutting module can generate accurate pattern blocks automatically, tailored to the virtual model's data. Finally, for production scaling, the system employs a unique 3D grading logic. This ensures that as the design is graded across a size range, the original fit, shape, and balance are maintained with technical accuracy. The result is a complete set of production-ready digital patterns that have been virtually fitted and validated. Rhinoceros is a precision CAD tool widely used in jewelry, accessory, and industrial design. In fashion, it's ideal for designing elements like buttons, zippers, belts, and wearable accessories. It allows for detailed and accurate surfaces, which can be directly exported to 3D printers. Rhino is often paired with rendering plugins, making it a powerful tool for prototyping and presentation-ready visuals. In the Rhino, the process begins with foundational geometry creation. We utilize NURBS to draft curves with mathematical precision. This initial line work establishes the core framework from which the entire model is constructed. Then, Rhino's robust toolset is employed to generate complex surfaces through operations such as lofting, extruding, or sweeping curves. For more organic forms, we leverage the software's subdivision modeling capabilities. After the primary forms are created, the next stage involves both macro-level transformations and micro-level adjustments, providing precise control over the final shape. To ensure model integrity, Rhino's built-in inspection tools are used to analyze critical properties like surface continuity and curvature. This validates that the model meets all necessary technical specifications for its end-use application. In the final stage, we focus on finalization for fabrication. For manufacturing processes like 3D printing, the NURBS or sub-D model is converted into a high-density, watertight polygon mesh. The platform's high compatibility also ensures seamless model export to other CAD, CAM, and engineering software suites. Adobe Illustrator remains a staple for digital textile and surface design. Its vector-based tools allow designers to create intricate prints, patterns, and motifs that can be seamlessly repeated across fabric. It's also widely used for flat sketches, line sheets, and tech packs. When integrated with other tools like Photoshop or CLO 3D, Illustrator enhances the creative process and prepares designs for both virtual and physical production. Let's look at the workflow for creating 3D-style fashion designs within Adobe Illustrator. First, we establish the foundation by drafting precise 2D technical flats. Using vector tools, we create the garment's outlines, including seam lines and construction details. During pattern development, we design all vector-based textile prints, graphics, and logos, ensuring they are crisp and fully scalable. To give the 2D flat a 3D appearance, we simulate dimension. Using tools like the gradient mesh, we realistically render light, shadow, and the curvature of fabric over the body. We then proceed with material application. The vector patterns are mapped onto the shaded flats, so the texture realistically follows the garment's simulated contours. Finally, we prepare the production design. This involves assembling a comprehensive tech pack, which includes the detailed 2D flats alongside the dimensional mock-up, to provide clear manufacturing instructions. The artwork is then exported for use in digital lookbooks, line sheets, and presentations, serving as a high-fidelity visualization of the final product. 3D CAD tools play a vital role in sustainability. They eliminate the need for excessive fabric sampling by allowing digital prototypes. This reduces emissions, shipping costs, and material waste. Designers can apply zero-waste pattern drafting directly in the software, cutting patterns in ways that leave no fabric scraps. Many platforms now track environmental impact, helping users make eco-conscious design decisions. From a sustainability standpoint, additive manufacturing enables on-demand, localized production. This workflow also presents a powerful opportunity for vocational education. A typical project involves a student designing a custom accessory, exporting the file, and printing it with recycled filament. This provides an end-to-end experience in modern product development, while reinforcing principles of sustainable, localized manufacturing. CAD tools also integrate seamlessly with 3D printing. This integration is revolutionizing rapid prototyping, small-scale production, and personalized fashion. The workflow is a direct digital-to-physical process. It begins with designing a component in CAD software, exporting it as a print-ready file like an STL, and fabricating it directly on a 3D printer. Within the fashion sector, this technology has several key applications. These include the creation of accessories like buttons and buckles, the rapid prototyping of trims, the development of complex footwear components, and the fabrication of sculptural garments for haute couture. This model allows for mass customization without the high costs of traditional retooling. With cloud-based CAD platforms, teams can collaborate in real time across locations. These platforms support co-editing, version control, and integration with tools like AR/VR. Designers, pattern makers, and manufacturers can co-develop products faster and with fewer errors. This is essential for global fashion brands and distributed teams. Cloud platforms like CLO 3D allow real-time file co-editing and boost coordination efficiency. We will now review a case study on Amberlin, a specialized training service that demonstrates how the fashion industry is actively upskilling its workforce in 3D CAD. Amberlin's services directly address a critical industry challenge: the gap between traditional design methods and the need for digital proficiency in modern product development. The core of their solution is targeted training in leading 3D software, such as CLO 3D. Through this training, designers develop several core competencies. They learn virtual prototyping to create and iterate on digital samples. They master digital pattern making for precision and immediate 3D validation. And crucially, they learn to apply principles of sustainable design by minimizing physical waste. The business impact for those who complete this training is significant. They can accelerate time to market through faster digital iteration. They can enhance creative freedom without the cost of physical samples. And they can operate more sustainably by reducing material consumption. Services like Andolin provide the essential training infrastructure needed to ensure designers can leverage the power of 3D CAD tools, making the design process more efficient, innovative, and sustainable. We will now analyze another pioneering case study. The Fabricant, a digital fashion house where the 3D garment is not a prototype, but the final, finished product. The Fabricant's model directly confronts the physical limitations of traditional fashion, such as material waste and creative constraints. Their solution is an end-to-end digital workflow that replaces physical materials entirely with data. First, for hyper-realistic material simulation, allowing them to design fabrics with physics and visuals that are impossible in the real world. Second, for virtual garment construction, where they build and finish these assets to the highest standard of CAD, DigiCouture. Through the Fabricant Studio, they offered users a new interaction model, where they could acquire and co-create digital clothing for use in virtual environments and metaverses. The first impact, it has proven the viability of a new market for digital-only fashion. Second, by never producing a physical item, it represents the ultimate form of sustainable fashion. And third, it democratizes creativity by breaking down the barrier between designer and consumer. They are not just using these tools to improve the current fashion system, but to design an entirely new one, a parallel industry that is more sustainable, imaginative, and accessible than ever before. Now let's review a practical task focused on zero-waste design. The objective is to leverage CAD tools to address a core challenge in fashion: fabric waste. The process begins by treating the fabric block like a puzzle, instead of conventional pattern cutting. They sketch all pattern pieces to fit perfectly within their boundaries, ensuring elements that would normally be waste are integrated as design details, like pockets or trims. Next is the digital drafting phase. The initial sketch is translated into a precise digital pattern. Using CAD tools, each piece is drafted directly onto a digital fabric block. This step guarantees perfect alignment and verifies 100% material utilization, with a level of accuracy that is nearly impossible to achieve by hand. The third phase is 3D simulation, where the 2D plan is validated. The pattern pieces are virtually sewn, and then draped onto an avatar using a physics engine. This provides immediate feedback on the garment's fit and aesthetics, completely replacing the need for multiple physical prototypes. Designers can also apply digital fabrics to observe how different materials will drape in real time. Lastly, the designer submits screenshots of the 2D zero-waste layout alongside the final 3D simulated garment. This provides a complete narrative, from the efficient plan to the final aesthetic, and explains how the design constraints directly influenced the creative outcome. This fully digital workflow offers dramatic savings in time, materials, and cost. It allows for experimentation with advanced sustainable practices, like zero-waste design. To conclude, 3D CAD design empowers you to create, visualize, and prototype garments without physical waste. It builds your capacity to innovate, collaborate globally, and lead sustainable practices in fashion. As you move forward, apply what you've learned to your design work, reflect on sustainability impacts, and explore CAD tools hands-on. Thank you for joining us in exploring 3D CAD design software applications in sustainable fashion. We hope this module has inspired you to embrace digital tools that drive innovation, reduce waste, and shape the future of fashion responsibly. Continue learning, experimenting, and leading the change. Let's shape the future of fashion, digitally and responsibly.